Hi, I'm Bob. Thank you for joining me as we work through the solutions to the exercises in the textbook Microeconomics, Theory and Applications with Calculus, the 5th edition by Professor Jeffrey Perloff. We are now in Chapter 15, which focuses on factor markets. We will address the first 7 exercises in Section 1 today. Here's exercise 1.1. What does a competitive firm's labor demand curve look like at quantities of labor such that the marginal product of labor is negative? Why? We first consider how to derive a competitive firm's labor demand curve and what it looks like. A competitive firm's first-order condition for a profit maximum is the marginal revenue product of labor equals the marginal cost of labor. In a competitive product market, marginal revenue equals the market price. So we can write the value of the marginal product of labor equals the marginal cost of labor. Or by defining the real wage as W over P, we can write the marginal product of labor equals the real wage. This is also the firm's short-run labor demand function, because the marginal product of labor is a function of labor. It can be expressed as a function of labor and wage. It tells us how the firm's demand for labor changes when the wage changes. The firm's profit maximizing behavior determines its demand for labor. We differentiate the wage with respect to the quantity of labor and find that its sign depends on how the marginal product changes with labor. The law of diminishing marginal product of labor states that the marginal product of labor reduces as the firm employs more labor. So dW over dL is negative, meaning that the demand for labor reduces as the wage increases. In other words, the labor demand curve is downward sloping. This is the case when the marginal product of labor is positive. Next, we consider what happens if the marginal product of labor is negative. A negative marginal product of labor means the firm's output decreases as it employs more workers. So the firm will not employ any labor at all, and therefore it has no labor demand. Let's solve exercise 1.2. If a local government starts collecting an ad valorem tax of alpha on the revenue of a competitive firm, what happens to the firm's demand curve for labor? The competitive firm's profit pie is as follows after the tax. The first-order condition for profit maximum is the partial derivative of profit with respect to labor equals 0. We know the marginal cost of labor is wage, and the marginal revenue is the market price in a competitive product market. And the last term is the marginal product of labor. We derive the labor demand function with the ad valorem tax. It looks like the standard labor demand function, but has one more term, 1 minus alpha. Compared to the labor demand without the tax for any given level of labor, the marginal product of labor is unchanged. So the new wage becomes lower with the tax. The firm's labor demand curve shifts downwards. Or we can think of it this way. The tax reduces the firm's effective price it receives. So it must raise its marginal product of labor to satisfy the profit maximizing equation. A higher marginal product of labor means a smaller number of workers employed due to the diminishing marginal return to labor. A reduction in demand for labor for every level of wage implies that the demand curve shifts down. Let's go to exercise 1.3. How does a fall in the rental price of capital affect a firm's demand for labor in the long run? In the long run, both labor and capital can vary. The capital demand curve is downward sloping. As the rental price of capital falls, the demand for capital increases. The effect of the increase in capital on the demand for labor is uncertain. One consideration is whether labor and capital are complements or substitutes for the firm. If they are complements, the firm may also increase the demand for labor. If they are substitutes, the increase in capital may lead to a decrease in labor. Let's address exercise 1.4. Oil companies, prompted by improvements in technology and increases in oil prices, are drilling in deeper and deeper water, using a marginal revenue product and marginal cost diagram of drilling in deep water show how improvements in drilling technology and increases in oil prices result in more deep water drilling. A competitive firm's labor demand and capital demand are as follows. They come from the firm's profit maximization in the long run. Because the oil price increases, the labor demand curve shifts to the right. For every given level of wage, the demand for labor increases. Similarly, the demand for capital also increases. The firm's production function is a function of technology, labor, and capital. We assume the marginal product of technology, the marginal product of labor, and the marginal product of capital are positive. Because all three inputs are going up, the output Q increases. That is why it results in more deep water drilling. Let's solve exercise 1.5. The quality of a dish Z is related to the number of gallon clothes G by this equation. Z equals 1/2 times G to the power of 1/2. Georges always fills his restaurant to its capacity, 250 seats. He knows that he can raise the price of each dish by 40 cents for each unit increase in quality and continue to fill his restaurant. Jacqueline, who earns $10 per hour, minces garlic at a rate of 120 gallon cloves per hour. For part A, what is the value of marginal revenue product? For part B, how many hours per afternoon does Jacqueline work? And part C, how many minced cloves of fresh garlic does Georges put in each dish? We know the relation between the quality of a dish and the number of garlic cloves in it. We also know the rate of mincing garlic cloves, 120 garlic cloves per hour. Other information includes the price of quality, $0.4 per quality, and the hourly wage, $10 per hour. There were 250 seats in the restaurant. We start with the quality equation. The marginal quality is the derivative of quality with respect to the number of garlic cloves. Notice that the marginal quality is for each dish. If the worker works for 1 hour, she minces 120 garlic cloves, which is 120 divided by 250 garlic cloves per dish. So, the marginal quality of hours of work is the marginal quality per garlic cloves in a dish times the number of garlic cloves in a dish per hour, which can be seen as the marginal product of labor. The value of the marginal quality of hours of work equals the price of quality, $0.4 times the marginal quality of hours of work. For 250 seats, the value of the marginal quality of hours of work should be multiplied by 250. The answer is also known as the marginal revenue product of labor. For part C, we equate the marginal cost of hours of work, the wage, and the marginal revenue product of labor to get the optimal number of garlic cloves in one dish. It is 1.44 garlic cloves per dish. For part B, the worker has to work for 3 hours to put 1.44 garlic cloves in each dish. Let's go to exercise 1.6. Show that the quantity of labor or capital that a firm demands decreases with a factor's own factor price and increases with the output price when the production function is Cobb-Douglas as in equations 15.12 and 15.13. For Cobb-Douglas production function, the factor demand functions are equation 15.12 and 15.13 in the textbook, where W is the wage, R is the rental price of capital, and P is the market price of the output in the competitive market. To find how the demand for labor changes with the factor price and output price, we partially differentiate the labor demand function with respect to the wage and the output price, respectively. As long as the sum of alpha and beta is less than 1, we have the result. The same approach applies to the capital demand. Let's answer exercise 1.7. The estimated Cobb-Douglas production function for a U.S. tobacco products firm SQ equals L to the power 0.2 times K to the power 0.3. Derive the marginal revenue product of labor for this firm. the marginal revenue product of labor equals the marginal revenue of the output times the marginal product of labor. In a competitive market, the marginal revenue of the output is the market price, P. For the production function, we can derive the marginal product of labor, the partial derivative of output with respect to labor. So we can obtain the marginal revenue product of labor. Thank you very much for watching this video and solving the exercises with me today. If it helps, please subscribe to my YouTube channel. Thank you. Thank you for watching this video and subscribing to my YouTube channel. See you next time.